Hi everyone, just wanted to take a minute to talk a little bit about piecewise functions. I'm just going to go over the basic pieces of information to help guide you so that way you can complete the activity that you have for today and have kind of the baseline knowledge to help you out. All right, so first off, let's start with a little bit of a warm up. So you have a relay race, and each runner is carrying a baton for an equal distance before handing off the baton to the next runner. Right, so you can think about it. You've probably seen one in the Olympics, or if you've gone to a track meet or something like that. Each person runs for a fourth of the time or a fourth of the distance, and passes it off. So if we were to graph the distance traveled by the baton as a function of time, so we're essentially saying, we're inputting a time, and that's giving us a distance. How is the speed of each runner represented? So really what we can think about is this going to be, a straight kind of continuous line, like that, or is it going to kind of be, mm, 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 right? So let's first off just kind of assume that each person's running at a constant rate. Might not be the most realistic, but, they're only running a fourth of a mile. Um, these are runners, so I assume that they are running for a pretty constant speed. Right, so here's my time, here's my distance, all right? And the first runner he's running for 3 minutes. So here's three, and here's like 0.25, point 5, point, let me erase that. I need to give myself more room. 0.75, and here's 1, right? So he's going here, and this next one, if here's 6, it's a little before 6, 9, 12, right? So 6 is kind of a little bit faster, right? And then 3 is a little slower, and 4 is faster, right? So as you can kind of see, based on that quick sketch, you can kind of see the different parts that we care about, right? This person is only dealing with this part. The second person's only dealing with this part. The third person's dealing with this part. The fourth person's dealing with this part, right? So essentially what this is it's no longer continuous. We're looking at different parts over the domain. And that's really what a piecewise function is, right? We only care about a certain part, or a certain part is defined differently than a different part. Right. So how would we figure out who the fastest runner is? Well, we would have to divide, um, you know, the time. Speed is distance divided by time, right? They're all going the same distance, and so whoever's lasting the longest, right? This one goes from 0 to 3, so that takes 3 seconds. This one goes from 3 to 5.75, so that's 2.75 minutes. This one goes from 5.75 to 9, right? So that's 3.25. This one would go 2.5, right? So this one would be the fastest, runner 4. Would end up being the fastest. But that's what we're going to look at today. So what's our goal? Well, we're going to be able to graph piecewise functions given domain restrictions, and we're going to create piecewise functions more tomorrow. But ultimately, we need to recall a few things, right? So the domain, those are all your inputs, right? Those are your inputs. So I can put in X, whatever I'm putting in for X, right? My X values. And my range, those are my outputs, your Y values, right? When you graph it, the Y value, you've looked at them before. Now we're going to look at them kind of disjointed. All right, and a piecewise function, it's just a function, right? So you have an input and output. Each input only goes to one output still, because it is still a function. So essentially what we're going to call a piecewise function, it's a function where the rule, so to speak, varies over the domain. And that's kind of what I mean by what we looked at in the last one, right? When we looked at it, it looked something like this, right? Like there's, 4 kind of different sections. That's what a piecewise function is. It's not a constant thing every single time. This part is slightly different from this part. This part's different from this part, right? It would be the equivalent of, me saying from 0 to 2, I'm doing x plus 2. And then from 3 to 4, I'm doing, 3x minus 1. And then from 7 to 9, I'm doing, 7x and so on and so forth. That would be what a piecewise function is, right? It's changing over the domain. All right, so increasing, right? You can identify what increasing would be on a graph. Successive outputs increase is probably the best way I can describe that, right? Like if I have an output of, if I put in 1 and I get out 2, and I put in 2 and I get out 3, that would be increasing, right? Because the outputs are increasing. Okay. On a graph, this is increasing, right? Decreasing is the opposite. That would be decreasing. So what we can kind of think of this is a successive output decrease, right? I put in 2, I get out 3. I put in 3, I get out 1, right? It's kind of going like, it's down. It'd be like a downhill slope. Negative slope. You could also think of it that way. Positive slope. You could think of it that way. Obviously, when we get to things that aren't lines, that doesn't necessarily make sense, but for our purposes now, think of it that way. All right. So, oops. Really? Let's think back a little bit to absolute value functions. You can actually describe an absolute value function as a piecewise function. And the way that you can do that is because if you essentially look at it, right, you have this part that's going down, it's decreasing, and then all of a sudden you're switching to increasing at the vertex. Essentially, what this is, on this side over here, it's this line, and then from this side over here, it's this line. We just kind of cut it off at a certain point. So when you're dealing with x greater than or equal to 0, it's the positive line. And when you're dealing with x less than 0, it's the negative line, right? So you're dealing with the absolute value of f of x is 2 times the absolute value of x. But it's essentially what, right? From 0 and beyond, it's just 2x. And from less than 0, it's negative 2x. So the way that you could write this would be you can write the function in terms of its pieces, okay? Each defined for a certain domain. So this is typically how a piecewise function is written, okay? So you'd have f of x is equal to, and the little curly bracket there, 2x, and in this part right here, this is the domain, okay? This is saying for you put in an x greater than 0, follow this rule. And when you put in an x less than 0, you follow this rule, right? So if I said I want to figure out what f of 2 is, I would look at this and say, okay, where does 2 fall? Does it fall in this one? No. Okay, so evaluate it here. All right. And essentially, this is what a piecewise function is. So if you looked at f of x equals 2 absolute value of x, you could write it in this regard. And you could do this with all absolute value functions, right? So if I tried writing this one, right? So what would this look like if I graphed it? It would look something like this. So now on this one, we're starting at the positive 3x, right? And we're going on this side to the negative 3x, right? So I could rewrite it in this way. And I'm saying I'm going to do 3x when x is greater than or equal to 0. And by the way, if you were, had something that shifted it, you just have to look for things that affect the domain, right? So, if I shift it up, that's not going to change anything. But if I shift it left or right and had like, -2 in here, you might be dealing with 2. Okay, so look at your x coordinate. Really look at, the axis of symmetry and tell me wherever the axis of symmetry is going to be where you define it. All right, and then 3x when x is less than 0. And if you want to test that, check a couple points, right? If I wanted, f of -1, well, where am I going to plug it in? Oh, over here, right? Um, so it would have to follow this one, right? And if I were to check like f of 7, right, where am I going to plug that in? Oh, I'm going to plug it in over here, so it has to follow this one. Okay. So one more. Let's look at this one and see if we could build it from there. So if we're looking at a piecewise function defined by the graph here, we can kind of look at it and say, well, there's two different parts, right? There's the left-hand side where it's increasing and the right-hand side where it's decreasing. Usually a change in increasing or decreasing or a very obvious kind of like jump is how you're going to identify a piecewise function. Some piecewise functions are a little bit more obvious in terms of their break. This one's pretty obvious, right? You go from increasing to decreasing. So how could I write this? Well, first of all, I should figure out what my equation is. Well, where's my vertex? It's -1, 0. Okay, so I definitely have an x plus 1, right? And what appears to be my slope? 1, 2, 3 over 1, so -3. So here's my function, and if I want to write this as a piecewise function, now we have to ask ourselves, well, where does it make the change, right? Well, it makes the change here at -1. My axis of symmetry, okay? So that will kind of be where my domain break happens, right? So if I'm going to write this, I'm still going to do the same thing. We just need to be careful because we need to write the correct equation. So this side, right, we're still going to do the same thing, x plus 1, right? It's just going to be from greater than -1. Okay. By the way, it doesn't matter where you put the vertex. It doesn't matter if you put it with this one or the other one. It's your call. See, like it doesn't matter because it's the same for both, right? That'd be the point of intersection of the lines anyway. Okay, and then so this one. So again, all I'm doing is just changing this one to positive, right? There's no difference. Okay, so hopefully that is helpful. You're definitely going to get some practice today with writing the equations based on delta math. All right. So here's another example where you have different lines that they wouldn't necessarily be an absolute value function, right? So here's what it would be when it's less than 2. Here's what it's going to look like when it's greater than 2, right? So depending on what part it is, we're making it look like this, okay? So then when we put it all together, you have this V-ish shape. And again, it's switching from increasing to decreasing. This is a pretty clear-cut difference. All right, so again, let's thinking about increasing and decreasing. So right here, right, we're increasing, we switch over to decreasing at this kind of point. That doesn't always happen, okay? So for example, here's another piecewise function. This is actually something called the step function. You can look this is a very complicated one to do, where basically we're saying we only care about integers. So as you can see here, there's a very clear-cut jump at each integer. -4, we have a jump. -3, we have a jump. -2, we have a jump. So on and so forth. Okay, so this is another example. Now to write this out using function, the piecewise notation, would be impossible. You'd have to set a certain restriction because each integer does that. But anyway, here's another example of a piecewise function just to show you that they don't always have to change from increasing to decreasing. And they don't all have to be connected. either, right? See, we have a little gap. Okay, so what you're going to do today is you're going to practice a little bit on delta math. You have some examples of writing piecewise functions based on graph. You have some examples of changing, graphing them based on the picture and evaluating and things like that. And then when you are done, please make sure you fill out the exit ticket and work on some of the homework, which is on a little bit more with piecewise functions. All right, have a lovely day.